Okay, this video is mainly for figuring out how to set up the oscillator. It's going to be unlisted, and it's building on this video, which is the Bindertronics configuring the PIC18F452. So I have open the setup more or less as that video had set it up, and I had left the default as the RC oscillator, which is like a resistor capacitor oscillator, I believe. I have to double check that, but I'm going to try and use one of the little oscillators, actually an 8 megahertz oscillator. So I'm going to have to select one of these according to the data sheet. As a note, I read in the C programming for the PIC microcontroller by Ward that the oscillator, that the analog to digital converter is set up for like the first 13 pins or something like that, and it needs to be configured. And I think that that's something I'm going to have to figure out here. That may be a separate video, but that's something I also have to troubleshoot. Page 17 of the data sheet, which hopefully I will leave a link for below, reminder to do that, starts discussing the oscillator configurations. I won't read all of it, but I'll read the first paragraph. 2.1 Oscillator types. The PIC18F452 can be operated in 8 different oscillator modes. The user can program 3 configuration bits, FOSC2, FOSC1, and FOSC0, to select one of the 8 modes. Low power crystal, crystal resonator, high speed crystal resonator, high speed crystal resonator with PLL enabled, external resistor capacitor with IO pin enabled, external clock with IO pin enabled. So since I'm going to attempt to use the 8 megahertz oscillator, it seems to fall into this category. 8 megahertz. So therefore it's the high speed crystal resonator. So I will read this. In XTLP-HS, I guess we are HS, which is high speed crystal resonator, or HS plus PLL oscillator modes, a crystal or ceramic resonator is connected to the OSC1 and OSC2 pins to establish oscillation. Figure 2.1 shows the pin connections. The PIC18F452 oscillator design requires the use of a parallel cut crystal. Use of a series cut crystal may give a frequency out of the crystal manufacturer's specifications. So the data sheet is suggesting pins OSC1 and OSC2. Pins OSC1 is pin 13, OSC2 is pin 14. And I'll have to look for some specific value capacitors for C1 and C2. I guess it's these here, so I can probably get away with the same value for both C1 and C2. And I need to set this up on a breadboard. See Table 2.1 and Table 2.2 for recommended values of C1 and C2. The series resistor may be required for AT strip cut crystals, whatever that is. RF varies with oscillator mode chosen. Alright, as I was troubleshooting, I decided on a change of plans. So I chose a 4 megahertz oscillator, so that is currently popped in to the breadboard, and I found some 47 picofarad capacitors, which was in bag 3 of my Alenco capacitor kit, and I see that I actually used those last time. Yeah, 47 picofarad. There is a comment that increasing the capacitance will increase the stability. Where did it say that? Higher capacitance increases the stability of the oscillator, but also increases the startup time. Okay, well, my next attempt is to go in and change the CON bits to the XT mode, since I'm using 4 megahertz. Okay, so here I am. The oscillator frequency is already set at 4 megahertz from last time. 6 zeros. Alright. Where is XT? Off camera, I have since set up the breadboard with the oscillator on pins 13 and 14 with 47 picofarad caps to ground, and I didn't add a resistor. The data sheet is actually unclear as to the value of this optional resistor. A series resistor may be used for AT strip cut crystals. I looked up AT strip cut crystals and didn't pursue it very far. But what's an AT strip cut crystal? I suppose if I wanted to pursue that, I could Google search it. I did a word search for strip. I don't really get this. Okay, so I will have to generate source code to output. And alright, so I guess I'll have to paste this in. So I'll grab it from, say, here, and pull it down to, I think, here, and I think I leave this in or something. Okay, so delete that. Okay, I forgot to copy all of this. Alright, so I guess I'll grab it from here. And I guess I'll just delete it so we can see it on camera. Paste. I guess this gets deleted. I hope that's right. Okay, I guess I'll try a save. Even though there might be some issues with this, I'll try to do a clean build. Okay, well, I did that, and surprisingly it worked. Okay, so maybe I will try and upload this even with this stuff in here. See if it'll upload. I'm going to click the don't show this message again. That's for the 3.3 volts. I'm not recording all of this while it's thinking. It says the programming is complete, but I can vouch that the LED on my breadboard is not lit up.